In this video, I'll kind of go over what the regression assumptions mean, and I'll explain it using some diagrams just to show what they mean. So in the textbook, right, the simple linear regression model, y equals beta 0 plus beta 1 times x plus the error terms, and the assumptions deal with the error terms. The errors are assumed to have a mean of 0, unknown variance sigma square, and are uncorrelated. In a regression setting, how we usually view the model is the response variable y is the random variable. That means that's the one where we are not sure what the value is, and we're viewing it as a random variable for each fixed value of the predictor. So typically we'll write the expected value of the y variable for a specific value of the x variable is equal to, right, the slope plus, the intercept plus the slope times the predictor, and the variance of your response for a specific value of the predictor is equal to sigma square. And the responses are also uncorrelated as a result. So, these are a lot of words, but I'm going to just draw a few pictures just to illustrate what these points mean. So let me just move it there, and we're going to take a simple example, right? Suppose in our data set, we have the values of our predictor, right, that we only have 4 values of our predictor: x1, x2, x3, x4. This will just be a simple example. So let's imagine a scatter plot of our x and y variables, right? And we have 4 specific values in this particular data set: x1, x2, x3, x4. So let's imagine we have these data points over here, right? 1, 2, another 2 data points, another 2 data points, another 2 data points. And then we'll say, well, the regression line that probably best describes this scatter plot is probably something like this, right? So that's our regression line, beta 0 plus beta 1 times x. All right, let me just erase that. Beta 0 plus beta 1 times x. Now, the first assumption is that, right, that the errors have mean 0. And so what this means is that for each fixed value of my x variable, the response variable, the average value of the response, is given by the regression on the straight line. So what do we mean by this, right? So if you look at this first fixed value, x1, when the x variable equals to x1, the average value of the response variable for these 2 data points when x equals x1 is indeed on the straight line, right? The errors, this is a positive error and that's a negative error here, right? The error is the data point minus the value on the line. These 2 values, the errors were averaged to be 0, and hence, so basically a byproduct of this assumption, right, where the errors have mean 0, is that the data points for each value of my predictor will be evenly scattered on both sides of the regression line, because then the average value of the response for these data points are on the straight line. Right, so that's what the first assumption means. Now the second assumption talks about the variance being equal to sigma square, and we said that the variance for each value of the x variable is equal to sigma square. The main thing is that this variance here, sigma square, is a constant value, right? It's not a function of my x variable, it's constant. So this means the spread of my y variable, so the vertical spread of my data points for each value of my x variable will be constant, and it's given by sigma square. So vertical spread over here, vertical spread there, vertical spread for those 2, and vertical spread for those 2, they are all theoretically should be equal to one another. So that's what this assumption means, where we say the variance, right, of the response for each value of my x variable is constant. The data points are evenly spread out, right, for each value of the predictor. The last assumption about the errors being uncorrelated, it's a little bit difficult to ascertain and to view that in a scatter plot. We'll be looking at some other plots in a future module to show what that means in context.